Walk out the door. Here we go. So, something I wanted to go over is the top of this page. If it'll work for me. There we go. And this is why we stay in our assigned seats so we don't talk. Okay, so normal distributions. I just went over this because I just wanted to go over it one more time. The mean is always in the middle. You should always be peaking in the middle like this. And it looks like a bell. If you have a butler service at home, which I'm sure all of you do, just kidding, you can have like your little bell thing that you have. Okay, it looks like a bell. Now, these ones don't look like a bell. This one, the mean's over here, the mean's over here, and this one I have two means. Okay, so that's why they're not normal, because those means are shifted, or I have multiple means. So speaking of that, a lot of this, because it's such a new topic, we have to go over what these words mean when I say it. When we talk about statistics, if you were here yesterday, we kind of just understood where we see statistics at. A lot. We see it everywhere. I keep stats on all of you. Every single one of you I have stats on. Okay? How you're doing in class. How you're doing your homework. How much are you doing your homework? Are you doing your homework correctly? Are you doing well on the tests? Are you doing good on the standards that are required for the SAT? Okay, things like that. I keep data on each and every one of you. The IEPs that you have, all data, all stats. Okay, that's what we're learning about. In every single career you go in, you will have to know a little bit about stats because it's everywhere.
That's why people take plenty of time.
For what?
Just overall, all that research.
For research for what?
No, I mean like the statistics, where you're getting all the statistics from. It sounds like it takes plenty of time to.
Statistics takes a while, yes. Statistics does take a while. Stop talking. Okay, the mean of a population is what? What is the mean of something? You remember from like way back when?
The middle?
Not the middle, that's the median.
What?
The mean is the what?
Total.
The total, something divided by total, which is the,
Occurrences.
The total added up all the numbers divided by how many numbers there are.
exactly, what's that called? It starts with an A.
Average.
The average. So the total, the average is basically what we did yesterday, the relative frequency. You take what happened, the occurrence, and you divide it by the total amount, and that's your average. Mean and population we talked about yesterday. Basically what I told the kids yesterday was a population is like all the high schools in the world. A sample would be Lockport. Okay, so a population is like the big grand scheme of things, and a sample is just Lockport. Okay, it's like a little piece. Yep. And then the standard deviation. We didn't talk about this yesterday, but we will today. Standard deviation is something you'll hear me say a lot. Probably the whole entire chapter, you'll hear me say it a lot of times. Standard deviation is of a population, and the sample is the same thing. You just have they're represented with different symbols. So it's a measure of how spread out the data is. So again, when we looked at the cell phones yesterday, we looked at basketball hoops and things like that. How spread out is the data? Is it really, really close to the mean? Or is it like super wide and spread out? And we'll talk about what that is in a second. So we have these three curves. You'll have to understand what each one represents. And I know that guy talked about the curves yesterday in the 2-minute video we watched. We have A, B, and C. All of them have the same mean. The mean is always going to be in the middle. So I'm going to put mean here. This is where your mean's going to be. Right in the middle. All of them have the same exact mean. Because they're all, the middle of all of them, all three, is right here in the middle. And I can even draw like a dotted line so you know, look at all of them are in the middle. Now the standard deviation is how spread out it is. If you notice, look how close the red one is to the mean. Look how it's kind of medium here in green, and in blue it's spread out. It's really far apart. Okay, we're going to talk about what that means. So what I want you to do actually for a second is just to take out your blue sheet, and we're going to fill in two things on the front page. We're going to fill out the mean and the standard deviation. That way you have it to refer to. So here we are. We said the mean was the what?
Average.
The average. Go ahead and fill that in. Because this sheet is the only one you will be able to use in the test, is this blue sheet. So make sure it's filled out.
What about a notebook?
Everything that you need to know is in here, I promise. Okay, remember I told you I'm trying to get you off of that notebook now. At this point, you're going to be seniors and you're not going to be able to use notes next year.
Exactly.
Standard deviation is a,
Sample?
I don't think a sample is it, hold on. Why is my brain not working right now? Give me a second.
A measure?
Don't worry, I have mine.
I think it's measure. Hold on. It is measure. It's a measure. So a standard deviation is a measure of how spread out the mean is from the data. So when I go from the mean and like the next option is like 10, that means it's 10 away. It's spread out. But if I said 50, that's even more spread out. So one big thing is I want to say is the lower the standard deviation, the closer it is to the mean. The higher the standard deviation, the more spread out it is. If I tell you the standard deviation is 50 and the standard deviation is 10, 50 is going to be wider because it's more spread out. So it's not going to be clustered around the mean. Now let's talk about something that's really important to understand with curves and definitely going to be tested on. If I asked you which one's more accurate, which one would you say is more accurate? A lower or higher standard deviation? Higher, because more of your data is closer to the mean. That means that you would want that. You want it to be close to the average. You don't want all these people spread out and your data to be all over the place. Okay, so when it's higher or taller, it's going to be more accurate. You would want that. Your goal is to get a more taller normal standard distribution graph. All right. So if the standard deviation for these companies is 0.1, 0.4, and 0.5, let's label where they would go. Where would you think the lowest, remember, try to look at this sheet that we just talked about. The lowest standard deviation means that it's A. So the lower the standard deviation, the closer it is to the mean, the more clustered it is. So I'm going to go right here and I'm going to put 0.1. Then it just goes up from there. So 0.4 and 0.5. Again, it's weird because they're decimals, but 0.1 is the smallest. That means that there is more data close to the mean or clustered to the mean. And again, that just means that out of our population of Lockport, a lot of us are about the average, that kind of thing, and not spread out. Okay? Not saying that that's always the case, but that would be more accurate. You would want A out of all of them. Out of every single one of them, A would be the most accurate because your data is pretty good there. You can actually use that for certain things. So let's talk about the back page here. Again, we should be done in like 5 minutes, and then you can do your homework and you'll be done. And then you can make up the homework if you were gone yesterday. It is measure. It's a measure of how spread out it is.
Oh, no, I was talking about so much.
Oh. Normal curves D, E, and F represent battery life of cell phones. We did that yesterday. We talked about cell phone battery life and how some people feel like their cell phones die really quickly and some people think that they have really very long ones. 3 different companies. Compare the mean of each company and compare the deviation. So all I'm going to do is I'm going to go D, E, and F. And I'm going to talk about each one of them. Which one has the greater mean? Think about what mean is. Where is the mean located? Let's just say for here. What do you say? The biggest mean. The largest mean. F, because it's super far away. So let's talk about what that means. Let me just go like this. Here is the mean. Here is the mean. And here's this mean. Think about your number line. If I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, wouldn't the bigger one be all the way to the right? Yes. So this has the largest mean. So the largest mean. And which one has the smallest? D. The smallest mean. And I'm not going to write anything for E because I'm not going to, like, the middle, I guess, the middle mean. But in between them, I should say. Compare the standard deviations now. Now when you talk about standard deviations, you're looking at the shape. So look at all of the shapes. What do you notice about them? They're all the same. So that's what we're comparing. They are all the same. Oop, are all the same. So I want to kind of put a little note here. You're looking at the shape of the curve. If the shape's the same, then they are all the same. But if it's wider, is it smaller or bigger deviation? If I were to like stretch it out and make it wider, would it be a bigger or smaller deviation? It would be bigger. Very good. Yeah. Okay, last part here. The standard test score of Washington Elementary produced a bell-shaped curve with a mean score of 83, and the standard deviation was 4 points. Now we have Hoover Elementary, and the school produced a bell-shaped curve with a mean of 85 and a deviation of 2 points. Now they just want us to kind of sketch a graph to see if you guys understand what this means. So let's draw one out. I'm going to draw 2 number lines, and I'm just going to put W for Washington, and I'm going to put Hoover, H for Hoover. Where does the mean go? In the middle. So I'm going to go ahead and put the mean on both of them. What was the mean of Washington? 83. Very good. What's the mean of Hoover? 85. So that always goes right in the middle of your graph if you're ever going to draw it out. Now the deviation just means that we're going to go from the mean and add 2 or whatever that is, and then subtract it. So we're going to add and subtract from the mean whatever the standard deviation is. So when I add 4 to 83, what do I get? 87. What if I add 4 one more time? 91. We're going to go more. I'm not going to expect you to know this today, but we're going to go more into that tomorrow. Now let's go backwards. If I am 4 away from the mean, but backwards, what would I be at in this next tick mark here? 79. One more time. Subtract 4. 75. Okay, so I'm just going to map that out. And maybe make a note of yourself that you added 4 and you subtracted 4. Just for notes. I mean, you would never have to write all of this out. I'm just showing you. Now let's talk about Hoover. 2 away. So what am I going to do to 85 to the right side here? Add 2. What's 85 plus 2?
87.
And again? 89. Now go backwards. 85 minus 2. And one more time. Good. And maybe make a note to yourself that we added 2 if you don't know how I'm doing that, and then I subtracted 2. So you always start at the mean and you go right and left. And this is what's cool about this chapter is you have never learned any of this. But it's so super new that you don't have to build off of what you've already learned in the past. Like, this is fresh. You could start fresh here. Let me ask you this. Which one is going to be taller? Because it has a smaller standard deviation. Is it going to be Washington or Hoover? Hoover. Here's why. The standard deviation is smaller for Hoover. Now, it's weird how that works. The smaller it is, the taller it is. Small, tall, they rhyme.
I thought it'd be W because he has 83 and the other one has 85.
But that's the mean. Now we're talking standard deviation. So we set ourselves up here. We're good to go. We set ourselves up. Now I'm talking about the height of it. So this one's going to be like tall, and this one's going to be like a little bit shorter. Like, meh. Okay? A little bit shorter. So that's all. I'm just kind of getting you guys used to it that this Hoover graph should be taller because it's a smaller standard deviation. So think tall, small. Tall, small. Okay? Last part here. It says to refer to your vocab sheet. So just get out the back page of the blue sheet. We're only going to fill in a couple things here. Just to understand, this is all vocab. It's not going to be a fun lesson like yesterday. This is not fun because it's vocab. It sucks. But you got to learn the words before we actually move on. So, vocab here. Let's go back. The shape of all normal curves are symmetric. It can be symmetric, which most of them are if it's normal. So what I'm going to do is I'm going to write up here, I'm going to put normal. If it's symmetric, you have a normal curve. If it's skewed left or right, then you're going to have a not normal curve. There's something called an outliner. And it's just a data value that is distinctively way outside of the data that you've, separate from the data that you've collected. So let's just say, like, you guys took a test. The average was like an 85. But then Joe Schmo hasn't been in school for like 50 days. And he came back one day and took it and he got a 2%. He's like an outliner. He's like all the way out there. Like, I shouldn't even consider him because he's not even really part of my data. He's an outliner. Okay, that's what that data represents. We actually talk about that a lot as teachers because that happens. There are kids that miss a lot of days and they're just completely different than our average normally is. So they're kind of an outliner. And then the center is where your mean is. I mean, that's just kind of repetitive here. The mean is in the center. That's probably one of the biggest things. And then your spread is how spread out, and we're using that term twice, or how far apart things are. And then we're just going to go back. Wait, hold on, let's see. I know there's one thing. Standard normal distribution we're getting to tomorrow. One last thing here, let's talk about it. For the following data distributions, describe the shape, outliners if there are any, the center, and the spread. What is something that you feel like you would know right away what the answer was?
The middle.
The middle. So the center is 200. And that's also your mean. I'm going to put mean next to it so that you know. Now the spread is how far apart you are. So when I go from 200 to 300, how far apart was that? 100. Very good. What'd you say? It's okay. So our standard deviation, I'm going to go all down here. That's called standard deviation. That little symbol. I'll draw it again. It's like a little circle, and then psh,
So like the upside
Kind
down
of.
Q.
it's like a cursive O kind of. It's a Greek letter mu, not mu. It's a Greek letter. What is Greek? Mu is the mean.
Oh.
This is the Greek letter theta. I think it's theta. Anyways, it is 100. But now let's talk about how spread apart the data is. Where do we start and where do we end?
Well,
100 to 300.
100 to 300. Very good. So I go from 100 to 300, but the deviation is 100. I just wanted to show you that.
but would the outliners be 100 and 300, which because they're out, like way out?
See, like, that's okay. We can have some over here, but here's what an outliner would look like. I'm going to put none. This would be an outliner. Like, if this was just a random, like, I collected all this data and I have only one person, like, way out here. That would be an outliner. It's really strange. We don't really use it often. You probably won't ever see it from this day on, but it's good to know that there is a thing called the outliner. The shape, what is the shape of this curve? The bell. There we go. Bell-shaped curve. A normal distribution, if you ever hear normal distribution, think of a bell. It's a bell-shaped curve. Huh? It is. But here, think about this. Look at, if I were to draw like that little, remember that bell I was talking about? Doesn't it look like a bell?
Oh, that's cute.
Ding, 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 ding.
No,
You've never seen one of those bells?
no.
I don't even feel sorry for you. Okay. All right. Now, just like yesterday, the homework's online. So if you weren't here, this is a perfect opportunity for you to get set up. This you cannot do on the phone because I don't think it's like it works. I think I tried it. I do have a I think we're using the charger, but I might have another one over here if you need one. So go ahead and go on to, it's called Edulastic, and I want you to bookmark the page. I had everyone that was here yesterday bookmark it because I'm already really liking it, and I probably will use it the rest of the year. So, it's called Edulastic. Edulastic. Edulastic.com. And let me get you the code. Log in through Google like you normally would, and I'm going to give you the class code in a second. I'll come and help you out. If you were here yesterday, then it should be ready for you day 2. If you were not, then I have to get you set up. Here we go. This is your class code. If you're just signing up. So your day 1 and day 2 should be on there. You have to make up the other one. I'm going to show you something really quick because I feel like a lot of you won't use it, and you should if you don't know. This is trying to eliminate you from guessing. If you go right here, take a look really quick. Eyes, 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 eyes. If you look here where it says hint, if you click it and scroll down to the bottom, if I scroll down the bottom, I show you an example on how to do these problems.